So, where we have a global manufacturing footprint, and for most important reasons are, number one, like I said, the technology is extremely complex. You have to tap the world's best talent, so tapping the global talent is one of the important reasons. Second one is, our customers have told us very, very clearly, their biggest nightmare is the supply chain risk. If there is a tsunami or if there's an earthquake in one of the islands, the whole semiconductor industry will come to a complete stop. We can't afford that. So we have mitigated the risk by spreading out our advanced technology manufacturing facilities around the planet. So we are growing. We're going to have more fabs in different countries as well. And the third one is being close to the customers. The advanced technology development, like Gary talked this morning about design and technology co-optimization from technology all the way up to the system level, is a very critical aspect. If you want to get a new node every 2 years, and it has to be optimized and serve the customers, you have to be working very closely with customers. So my group is responsible for that, the advanced technology architecture in GlobalFoundries, and I'll talk a little bit more about that. So we have the world's most advanced fab that we are building. We actually built. We're expanding beyond where we are today in Malta. Just a quick view of what it looks like inside the Fab 8 clean room. It's very, very advanced. To give some stats, it's over $8 billion overall project. It's the first leading edge foundry fab in the US, the foundry. And so you look at all of those numbers, it's mind-boggling. It's really mind-boggling. And, oops. So we have to keep that in mind. The foundry economics is a big piece that's not something that you can ignore. Let me talk a little bit more about advanced technology. In terms of the challenges of advanced technology, we talked about research. We heard that all day long. There are quite a few things there, but we do collaborate with both IBM and with IMEC. We make sure that we have visibility into the next few nodes. And then as the technology architecture, which is what I'm responsible for at GlobalFoundries, and it's very, very important that we define the technology right, that it is cost effective, it's manufacturable, and so on and so forth. And then it gets into development, the development cost and the timeline challenges, because you have to make sure that you're getting your manufacturing cost under control right in the beginning. It doesn't happen later on. I mean, you can still reduce the cost later on, but there's a lot of things that you can do upfront, and you have to do that right. And then, of course, in the manufacturing phase, it's all about DFM and e-learning and improving the defect density. It's a very complex trade-off. I won't go into each of them. I can talk about this for hours. The application coverage right at the beginning is very critical, because you cannot have multiple technology nodes developed in 2 years. You have to have thought through all the applications, whether it's FPGA or networking or CPU or graphics or mobile computing for that matter. All that has to be thought through, and the requirements have to be fed in upfront. And you got to look at the production risk as well. So you got to manage this extremely carefully to bring up a new technology node. The semiconductor ecosystem is really, really complex, from system level to EDA tools to everything there. But at the heart of that is really the advanced technology. We do have visibility for the next 2 nodes, and beyond that, of course, the R&D collaboration. Our GlobalFoundries R&D engineers work very closely with Gary's team, and the R&D collaboration goes on. We also have, we are also partners with IMEC. So there is enough visibility for the next 2 nodes, but beyond that, we have to see. There is also these silicon photonics and the optical I/O technology that has to come up, because it's crucial. But then how do we really do it? Like I said, we're really collaborating with the world's most advanced R&D ecosystem, with the equipment suppliers, with the material suppliers, with the technology, with the academia, with IBM, with IMEC. We tap into every single R&D ecosystem that's possible to make sure that we are on the right trajectory. The next part of it is more than more. After having the advanced technology, you have to look at a little bit more than that, because there are some critical aspects of more than more. For the SOC, there are some critical enablers, the RF, the high voltage, non-volatile, all these are critical pieces. You just can't ignore them. There is also another level of migration. There's a number of mature technologies and the solutions that are moving from 200 to 300 millimeter. And if you see some of the SOC solutions today that were previously in 200 are now all moving to 300, and that's another thing that you need to keep in mind. There's also the interposers that allows you to develop your blocks, or the SOC blocks in whichever technology it is optimal, and then integrate them. That has its own trade-off, but also it's optimal for certain things. There's the 3D and the 2.5D memory. All these are more than more solutions. It's another critical enabler. The 3D and the 2.5D memory is, of course, another critical enabler. And the through silicon via is also a very critical piece. I'm sorry, in the interest of time, I'm trying to run as fast as I can. But overall, more than more drives new solutions, and it's as critical as advanced technology. So we have to remember that without more than more, we may not have had all the semiconductor growth that we are enjoying today. Now, but there is another dynamic that I want to highlight, which is because of all of these, the conventional approach was what I showed you earlier, but more than more is also getting closer and closer because of a number of things, a number of solutions are moving into a little bit more advanced technology than in the past. But it has some benefits. It actually extends the life of the process, right? It also improves the ROI on the large investments that are made. In summary, the critical enablers of future semiconductor growth are, number one, the true collaborative R&D for all the reasons I just discussed, and then a real model to enable differentiating customer solutions throughout the process cycle, not just the advanced node, but you have to look at critical solutions on the advanced node, on more than more, and all through the life of the process. And more importantly, from a supply chain risk, like I talked about it earlier, end of the day you can manufacture everything you want, but if you can't get it in time or there are supply chain risks, then you have failed. So the global manufacturing footprint is also very critical. GlobalFoundries strategic initiatives and the investments that we're making is focused on making sure that all of these are taken care of. Thank you very much.